Today we will solve this problem regarding the activation energy of a reaction involving the frequency factor. So this is the problem we have at hand. Calculate the activation energy EA in kilojoules per mole for a reaction at 55 degrees Celsius that has a rate constant of 0.201 second inverse and a frequency factor of 9.95 times 10 power 11 second inverse. The starting point for pretty much all the problems involving the rate of a reaction and the activation energy is the Arrhenius equation. The Arrhenius equation is given by K equals A times e power minus EA by RT, where T is the temperature. Here it is given as 55 degrees Celsius, and we can convert it into Kelvin. So it will be 273 plus 55, which is 328 Kelvin. And K here is the rate constant, which is also given as 0.201 inverse second. And A here in this equation is the frequency factor, which is also given in the problem as 9.95 times 10 power 11 per second. R is the gas constant at 8.314 joule per Kelvin per mole. So if we put all of this together, we get the Arrhenius equation. Now, since we have to solve for the activation energy, we can rearrange this Arrhenius equation. We can start with isolating the exponential part of the relation. Then we will have K by A equals e to the power minus EA by RT. Now, since the activation energy we need to calculate is on the exponential of this equation, we can take logarithm on both sides. So that will give log K by A equals minus EA by RT. Now we can rearrange it again to get an expression in terms of the activation energy EA. So we get EA equals minus RT log K by A. At this point we have almost completely solved the equation. Now all that is left is to substitute the values we were given in the problem itself. So that is straightforward step. We can plug all these values in, and then we will get a value of activation energy as 34,618 joule per mole. And since we are asked to find the activation energy in kilojoules, we can divide it by 1000. That will give the final answer as activation energy equals 34.62 kilojoule per mole. Now if you want to make this process simpler in your future problems, maybe you can consider remembering this equation for the activation energy EA equals minus RT log K by A, which is pretty much identical to the Arrhenius equation, just written in a different form so as to calculate activation energy. Hope you like the video. If you like it, please like and subscribe. See you next time.